Welcome to Muse and Metrics. This is your host, Philippa Burgess. This is Season 5, Episode 18, and today's topic is Inside Machine Learning.
Hi, my name is Rahatara Ferdousi. So I am currently a PhD candidate and I'm mainly exploring the generative AI. Also, I am one of the Women Techmaker ambassadors, and beside my study and the community work, I also am teaching part-time at St. Lawrence College. So now currently I'm living in Ottawa, but I'm originally from Bangladesh. So that's a brief about me. And ever since I was young, I have been always passionate about creating something new, and this led me to pursue the degrees or my study in computer engineering. And I also wanted to share knowledge, which is why I found teaching very fulfilling, and it's not just a job for me, but it's what I love doing. Techmaker ambassador is this program is something for me that I really want from my heart, because I started with the program when I was just an undergrad student, back in 2015 in Bangladesh. And back then there wasn't much support for women intake at my university, so I really had to work hard to set up the Women Techmaker club and organizing the workshops, arranging training sessions. And now seeing some of those members become the Women Techmaker ambassador in North America, or maybe being a community lead, or a GDG organizer in North America. That is something really, really fulfilling.
Oh, that's fantastic. And I have found that the program for me was completely transformative. I discovered it just as I was starting in my sort of science graduate studies, because I've kind of come from this sort of art and entertainment background. And it was a really great way to acknowledge that I'd stepped into studying sciences and computer science. And my focus in computer science is in the geographic side of it. And now we're finding ourselves really leaning into machine learning. So I'm super excited to talk to you a little bit more about machine learning, because we use it in spatial analysis, because with spatial analysis, you have raster data, which lays over something like a sheet. You also have vector data, which is like points, lines, and polygons. And the vector data, so it's images, pixelized data, which is typically collected through drone imagery or satellite imagery. So we're now at the place that every day, every inch of our planet is photographed from satellites. So machine learning can be super valuable in that space as far as image categorization, change detection, and predictive analysis. And so I'd love to sort of just do a little bit of more deep dive in terms of, because I'm so new to machine learning. I understand it conceptually, I understand some of the tools, I understand some of the libraries and packages you can use. But just, I mean, from your point of view, because this is your field. What do you what got you interested in it? Let's start kind of there, and then we can sort of get more into some of the technical aspects of it.
I think it's been now long I'm working in machine learning. The first paper I worked on, the first project I worked on, that was a very simple machine learning project. And that, I think I did it very innocently. I didn't have much idea about the data. I was focusing on the goal, what I want to achieve from those data. But more, I stepped into machine learning, and I started to do a project with real data. For example, I have contributed to one of the National Research Council's Canada project, where I was working with the images of defective part of heavy freights, defective parts of railway. So slowly I understood that it's really important to understand the data, what data you are working with. So understanding your data is a very important part. If you focus on that part, I believe that then the next part where you will maybe selecting, like you mentioned that you are familiar with kind of algorithms and like some libraries. So if you understand the characteristics of a data and the goal, like what you want to retrieve from the data, I think like that those are the first thing you have to consider when you are working on any kind of machine learning project. And then based on those information, you have to select, like you can select your models or whatever library you have available, because also it depends on kind of feasibility of the algorithms and the the applications you are looking for. Because if you don't have something to ease to implement, and also to consider some factors, like you need to train maybe your model with lots of data, sometimes with real time data, especially you mentioned that you work with spatial data. So for those you need to consider several factors. So I believe like designing your designing the requirements from your machine learning project, that is very very crucial.
You make a great point that a lot of the data that is given to us by our professors, they emphasize this is clean data. This is not what you're going to get in the real world. And now our final project, it was like kind of you're on your own. Go find your data. Go clean your data. Go
Yes.
put your data in databases and do your own SQL and get it going and make it
Yeah.
fabulous. But it was just, and I did pull all sorts of data set, and I'm looking at them, and they're all over the place. As far as actually, it's kind of next step for me is to go in and now actually figure out how to organize this data, and the quality of the data and the cleaning of the data is a huge part of data science and data analysis. It's not the glamorous part, but it is really, really important.
Exactly. Like I totally agree. Like cleaning the data or like preparing your data, which we call the pre-processing stage, that that is something very very like labor intensive. Though there are kind of new technologies, for example nowadays, like there are data augmentation, like there are algorithms, or there are like library functions to do these steps. Still you have to understand, right, like what steps you need to do to clean your data. Because if your data is not clean, the idea is kind of simple. Like for example, if you read like poor information or poor quality resources to prepare for an exam, of course you will not do good. So this is the same thing for the data. Like if you don't select your data wisely, or if you don't clean your data and prepare it for your model, I like the ultimate outcome will be like your model will not perform better.
Yes, that makes a lot of sense. One of the things, this is a very basic question, and haven't quite understood this. When it comes to machine learning, and you have a data set, and you're running it through the data model, and it comes out, and it's kind of a percent accuracy. And in like the first intro to ML, and we work with penguins, they're like, oh look, it's 98% accurate. But most of the time they sort of say, hey, 60, 70, 80% is fine. But the question is, well, what if you don't like 60, 70, or 8? Like, what do you do to actually fix it? Like, can you fix it? Can you get it to be better? Does that question make sense as far as?
Yes, absolutely. Like that, I think that is like a very, very, very basic and like original question, like that. That happens kind of in all of projects, no matter whether it's a research one or maybe like a product one. Because like if you have seen kind of papers or like the products claims, mostly they say that okay, we have 98% accuracy, we have 99% accuracy, or maybe we have improved the accuracy by 1%, maybe 0.5%. But like uh, with this particular term or matrix accuracy, we just like uh, get one kind of information that okay, this model can perform this level. But based on how much data, or maybe uh, like obviously, like when you are training your model, you are using certain data set. So that accuracy is particularly for one kind of data set, and maybe not applicable for a wide range of data which your model may need to deal in future. So that is kind of very very like risky to claim something, but still we are saying all the time like, okay, there are this much accuracy and my model perform the best. But I think there should be something to regularize the model's performance. For example, there are kind of mechanisms that helps you to like to subdue the overfitting issues, so that your model doesn't assume something, like it's not like overfit with the model. So in that case, like I think we can get little bit reliable information about the accuracy.
So with the accuracy issue, and maybe this is where I'm like so new to this, and I'm sure many of our listeners are as well. When you're getting in, so do you got to go back to your data and do you say, hey, I can make my data cleaner? Like there's ways that I can just improve the data to help? Or when you say work with a model, let's define that. Because for
Mhm.
example, I know like I'm so at the beginning, I know for example, like TensorFlow is one of the tools
Mhm.
you can use. I know there's a few others like Scikit-learn and IBM Watson. So those are sort of like three basic ones that I know. So let's start there. Like what
Mhm.
tools do you use? What's what are the go-to when you're building a
Mhm.
model? What do you use?
Yes, like one of the thing is with data, and like there are metrics or there are parameters that we consider for, like, okay, let me correct this. I think the term should be parameters for the model. So there are two things, like of course with your data and also with the model parameters. Because if you come to data, so you cannot include data in your test, like you cannot include the training data set for testing. For example, when you are claiming the accuracy, you must be claiming one certain test data, and those data should not be part of your training data. you know and again, when it comes to the model parameters, for example, there is one parameters which we call epochs. So if we increase the number of epochs to 100, let's say for 100 images, of course, like that accuracy will be so high. But that is not how we should do it, because like that means you are training your data again and again with the same model, and your model is kind of assuming that, okay, these are the data maybe I will be always seen. But that doesn't justify your accuracy, right?
Yes. And so it's basically saying, I can get you at 100% on just this, but when you see new
Mhm.
data, you're not going to know what to do with it. You're
Exactly. Yeah,
and so
exactly.
by sort of lowering that, so this is so I actually haven't gotten it. This is where I'm so at the beginning. I'm aware of what the tools are. I'm aware now of like what the
Mhm.
value is. I'm seeing how it's used, and I'm in a lot of conversations about it, but I haven't
Mhm.
yet to sort of open up TensorFlow or open up uh, Watson or Skyscanner. Now I have done like the one on Colab where you kind of do the
Mhm.
exercise and you kind of go through it, and I
Mhm.
think that one does kind of pull in TensorFlow. But again, that's just so super basic. So now I'm
Yeah.
understanding it from you. When you say build a model, you have
Mhm.
parameters, like you get to set like do this, 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 and this,
Mhm.
do this, 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 and this, and then you
Mhm.
see how it works. And then if you don't, and so you keep adjusting it until you get
Mhm.
something that is your model.
Yes, exactly. Like tuning the parameters and obtaining the generalizability. I think that is the more specific term. Like by generalizability, we mean the model, should work good on the unseen data, which is the practical scenario, right? When you build some model and you expect it to predict, uh, when you deploy those as application, of course, like it will receive some data which it hasn't seen during the training. So all you can do is like let your model understand maybe that certain kind of characteristics or patterns, especially in case of deep learning models.
Okay, and then let's talk about that, both for my own benefit and for our listeners.
Yeah, sure.
So I understand sort of, the big circle, the big tent here is artificial intelligence, and then
Mm-hmm.
machine learning is a subset of that, and then deep learning is a subset of that. Now, so
Mm-hmm.
what I understand, and again, I'm applying this to sort of things I'm learning in the geospatial space, is that machine learning is really good with structured data, with tabular data. So it works particularly well with anything that, again, is on a spreadsheet as far as the
Mm-hmm.
data. But with deep learning is much better for pixelized data. So that kind of image, that satellite drone imagery data is much more deep learning, as is, for example, if somebody pulled like a thread of tweets and sort of and was looking for sort of sentiment and other things that were sort of in unstructured data. And so that deep learning is more for unstructured data and machine learning is more for structured data.
Um, well, for deep learning, I agree with you, but for the machine learning, because like we consider machine learning and learning as like, supervised, semi-supervised, and unsupervised. So, of course, the supervised algorithms or supervised machine learning is better for the structured data where we know the properties of the data, and as we mentioned, maybe in the Excel sheet or maybe in the CSV file where you have the characteristics of the data. For example, I have worked one project. It was for early stage diabetes risk prediction. So for those, we had the age, kind of like symptoms and the levels, for the for every patient for each instance. For those, the supervised machine learning models, which are basically classifiers, those work better. When it comes to deep learning is like semi-supervised machine learning. Like both are machine learning, but like deep learning is a kind of semi-supervised machine learning where we basically deal with data where those are hard to characterize manually. For example, like when I am pronouncing some word, let's say environment, and you are pronouncing the same word, like there are very much subtle difference between those pronunciation. So when we obtain audio data from those words, those have kind of features which are not very much defined or structured to identify. So deep learning model works on those data. For example, images, because images can be from different sources, so it's hard to characterize. Like of course, before people have worked with image data with supervised machine learning model, and still they are doing this. But deep learning has become very popular because all you need to give the model is the label. So like what is this stuff and the data, but you are not saying, okay, these are the properties of the data, like the image has like this color or maybe this texture. You are not providing those information specifically.
But structured and unstructured. So, and then sorry, we were talking about supervised and unsupervised. So, what
Mhm.
exactly is supervised or unsupervised? It's,
Mhm.
I mean, supervised is not like I'm
Mhm.
sitting at my computer watching it. Unsupervised, I've walked away to the kitchen. Like, what exactly is
Mhm.
supervised and unsupervised in an actual workflow?
Well, like for supervised, I would like to go through examples. Like for supervised, you are giving the model the label, and also you are giving the model the data with its specific characteristics. For example, if you want to tell the model that, okay, this is an apple, so you will give the image of the apple, you will give the label, the text apple, also you will give it the color of the apple, like the red text and the texture, like yeah, like with some image processing you will find out those, and you will provide those specific features. Like you will do some feature engineering and you will give those specific features manually to the model. You will be the one defining this. When it comes to the deep learning model, then let's say you just give the image of the apple and you just give the levels that, okay, this is an apple, but you don't give the specific characteristics like those red colors or the textures.
You kind of let it figure it out by what it sees, and then it sort of goes through enough of them and then it figures out
Yes,
that.
like the model, the deep learning models are like structured, or the architecture of the deep learning model works in that way, so that the model itself understand like which features will be important, and they do it with a process which is usually a back propagation. Like this is kind of a technical term, but it means like the model each of the time shows like takes the input, like takes the training data, let's say the image of the apple, and like then it tries to understand, okay, like these are the highlighting features that are important. So decide those are decided by the mod, like by the deep learning model, like the machine learning model you are selecting, while in case of the supervised machine learning model, you are the one who are defining it manually.
Okay, then no, that helps. Now, on let me ask a couple questions just as a
Mhm.
learner, as a student in this. I mean, I have had such a deep learning curve, steep learning curve, deep and steep learning
Mhm.
curve in geospatial, just kind of understanding how to use the software. And part of the challenge of geospatial is that we live on a bumpy ellipsoid. It's not a sphere. It's very, it's got all these kind of unique features, and then it spins, and it is basically it's squished at the poles and it bulges in the middle. So getting the math right on all of that, and then when we look at maps, they're flat, and obviously we live in on a sphere, so there's you have to kind of project it, and there's different projections, and every single one of them is going to
Mhm.
have a distortion, whether it's a distortion of size or distance or um, location. Like you have to make choices when you make flat maps. So the question then is, for me, I'm happy that I've gone down this sort of field of study, and now I feel like after a year, more than a year, I'm actually at a starting point. Like, okay, now I'm really like ready to get to that next level, and I'm really happy I have at least another year in school to really like do deeper dive. And I'm just starting to sort of put my interest into machine learning.
Mhm.
But on one level, I'm like, is this a fool's errand for me to sort of start down this path, or will I get there? And what is I'm sure there's many levels of the learning curve, and
Mhm.
obviously you're in a PhD
Mhm.
program. So what level, what advice do you have for somebody like myself who sort of is able to study full time,
Mhm.
or for someone else who may work a full time job and says, I'm interested in machine learning, but I don't have that much time to commit to this process. Where do
Mhm.
people start, and what can they expect in terms of the breadth and depth of the path?
Okay, that's a very interesting question. I would say, like in one words, the like best way to do with the like this is like to be being successful with your data and your model is to live with it. To live with your data. Like initially, whatever projects I have done since now, every time I thought, okay, like I don't think this data are very complicated, this looks simpler, maybe it will be easy. But it was never the same thing. Like even the data, I thought that, okay, this is the easiest one, this is structured data, this is just textual data. Every data has kind of different sort of information, and like uh, every data has kind of different sort of patterns, right? And like they if you want to learn about like how these models are working, you can kind of make your own research on the similar data, and at least on the similar types of goals that others are trying to achieve, maybe through some machine learning model papers. For example, I think nowadays GDC has some study group where this is called like maybe a machine learning paper or machine learning research paper study group. So if you attend kind of those things, and you just try to summarize like what other people have done with the similar types of projects, then you can at least get some filtered information, and with those the learning path becomes more smoother, than like starting from it from scratch, and trying out, and like it's kind of going to trial and error process all the time, you know. Where, like, I wanted to convey that, let's say, when I started my first project, I saw, okay, this is the data and I know this kind of machine learning algorithms with TensorFlow, so let's start with this. But this wasn't the right thing to do. Later I understood that, okay, what I am working on, maybe some other people are working on. So I started to look into the open source contributions, like projects from GitHubs and like some tutorials, some research papers. And then I, usually um, try to look for two things. First, like, what kind of challenges other people have faced with that, what's the differences between those projects and mine, and the, of course, like, the required things to build those projects.
That makes a lot of sense. I know I'm working my way through some of the Google Coursera courses in data analytics and advanced data analytics and project management, cybersecurity. And I know some of the modules are coming up are machine learning. So I have a feeling like they'll be very structured and very much about learning the concepts and probably giving you some sample data that's very clean and very simple to sort of understand to kind of give us a starting point. I think there's a fine line between kind of going through tutorials and sort of using them to sort of get that starting point and then transitioning into actually doing it on your own. So when I was in college a long time ago, basically in the early 90s is when we were, it was HTML, and I was like, oh, I can prop up a website. And then I did a lot of marketing work where propping up the website was the job. And this was before all of the easy plug and play things we have today. And so now I'm kind of going back to it. Like the project that we're talking about is like, oh, back to writing HTML. But now it's like, and Python and JavaScript and working with ArcGIS Pro, working with the Google platform and putting all these pieces together. And it's very much like always been part of my interest, but I think I needed a structured program to really help me focus and develop those skills further. I mean, even doing Women Developers Academy, I was like, wait, there's no coding. It's all public speaking. I'm like, I have public speaking. I definitely have public speaking.
Yes.
So what was your experience with Women Developers Academy?
Oh, that was great, because, like, in my case, that was totally opposite from the feeling that you had, because, like, I was more looking into the, public speaking kind of training again, because when I moved from Bangladesh to Canada, there is a language difference and there is kind of a cultural shock. You sometimes get it. So, though I was, a lecturer back home, I kind of was, like, suffering from imposter syndrome. And, like, I was just underestimating myself, that thinking that, okay, I think I cannot do the public speaking back again. So this program really boosted my those skill back again, like it kinds of give me those strength back again. So I'm thankful to Junaid and all the program coordinators for those. And, like, yeah, that helped. And I have been talking into the, like, on the dev fest, I have talked in Ottawa in my program. I will be talking in Saskatoon and also in Miami. So, like, that is very like, that was very, very, fruitful for me, because I was looking particularly on something that helps me, to uh, to come up with a very fine-tuned technical presentation that I can at least present on those Google standards conferences. And also I wanted to, boost up my like, confidence for public speaking again.
Oh, that's great. Yeah. And I think for me, it's like I've always loved to speak, but I think I'm new to owning this identity as a woman in tech and a woman in STEM. So it's really great for me to be able to put that together. And
Yeah.
of course, hear and learn from everybody else in terms of what they're talking about, but also seeing, like, for me, that within all these amazing tech women, I'm the only one sort of in the geospatial space. So
Yes,
I
that's
actually
very
just,
interesting.
but it got me to also raise my hand to go network with other women in geospatial. So I just joined a global organization called Women Plus in Geospatial. And now I've got 4,000 women who are in
Oh, that's
geospatial.
amazing.
So I'm really enjoying both. I'm enjoying being part of the Google world, but I also
Mhm,
realized that I was like, I need to also equally find other geospatial people to talk about
mhm,
with. And that has
mhm,
been really nice. And then with my content, I've just launched a
mhm,
YouTube channel specific to maps data design. So one of
mhm.
my goals is I've been doing the podcast for a while, I'm coming into my third year, but I really want to sort of start doing more video. That's my like new goal is
Yeah.
to
I think
really.
Yeah, I think that would be wonderful, because you are kind of working on something very innovative. And as you mentioned that you were trying to take the Google courses, I found Google courses very, very helpful, especially during the International Women's Day or during the Deaf Fest. Every time they, bring huge resources, which are basically workshops or, technical talks or training with Google Colab notebooks, and kind of sometimes with interactive training and labs on Google Skills Boost. Those are very helpful. Those gives you at least those the technical confidence that you need to achieve. Like for example, you are saying that, okay, I have done coding long ago. I'm not sure like how maybe I will start with this one. So those kind of confusion or like confidence level, that can be really, really benefit from the Google courses. Not only from the one that like those are available on those, but as an Women Techmaker ambassador also, sometimes we receive workshops and like training on workshops. For example, I got on from TensorFlow for introduction to AI. That was really helpful. Like I think I still give one lecture when I am taking the Python programming course in the college. I try to give one lecture on those topic, like fully on those training.
They're super helpful. I've been enjoying those, and I just started a Google Cloud Skill Boost, and so I'm working
Mhm.
because this project, in theory, you can run it from Cesium or you can run it from Google. I think ideally, like I really want to learn how to launch this whole thing from Google, but I
Yeah.
got sort of tangled because there's so many pieces to the console, and I realized I'm like I don't really understand all of them, so I'm just going to go ahead and like baby step it. I'll just start it from the Cesium side of it, and it's something I want to learn. And I know, like I said, there's also the machine learning engineer in that training
Yeah.
program. But I realized I'm like, I have to start at the beginning, which I think the first one was like Google Cloud or Google Digital Leader is the first one.
Mhm.
And then you get to be like kind of cloud engineer, and then you can kind of add the specialties. And I was like, yep, I'm going to start at the very beginning and just go. But I have a whole map on because I'm trying to learn so much, and I graduated in December of 2024. So I'm like, okay, I've got a year to kind of do all these courses and trainings. And they're a lot. Like they actually, I
Yeah.
realize if I don't do, I have a whole map, but basically, if I don't do like 15, 20 minutes a day, it won't happen. But if I'm very consistent about 15, 20 minutes a day, I will continue kind of to get all of these things. And
Mhm.
so I think, but it's amazing to me that they're all out there. Most of them are free and or
Yes.
very nominally priced. And they definitely build that confidence and you
Mhm.
when you start from sort of nothing and you're like I don't even know where to begin, and they walk you through it very systematically, and they give you tools and resources, and they point you in the direction of all the organizations and other tools and other things. And I think part of it is also not only just learning how to do it, but kind of who are the players in it, who and how and where's the vocabulary
Mhm.
that goes with any particular thing. So I think they're very well structured, and I think they're incredibly well delivered, and I think probably underutilized.
Yes, of course. And as you mentioned, like about your project, I would say like that is a very, very ambitious one. So like I would highly recommend you to like go through the courses, look into the open source projects which are similar, and yeah, just keep going. I think you will figure it out, because it will take some time to get the grasp on this area. But of course you're gonna figure it out, because there are huge resources from Google and from other open source communities as well. Yeah. I think like you mentioned that like you are using chat gpt, and sometimes you really feel empowered when you are using that. So I think that's totally fine, because chat gpt is a great tool if you can like use it smartly. And I found a very interesting course, like not a course, it was a lab from the Google skill cloud skill boost, one prompt engineering. So the better you write your prompt, that like chat tool, the chat gpt, or like bard, similar tools like chat gpt, those language models can be a great assistant. You can save time, or like not necessarily nowadays you have to remember all those syntax library functions. You can, of course, like you can use chat gpt for those, so that at least you don't spend a lots of hours on fixing the syntax. And like when I used to like I used to work with a new program, and like as a beginner programmer, every time I really had very hard time with the syntax. Like I was missing a very single things, and I was spending the like spending night after night to find the errors myself. But now it's very easy. You just copy paste that snippet, and like you just ask ChatGPT, and if you ask it with the right prompts, I think it's like it gives you the great answers. Also with Colab, I recently figure out a very nice thing. It is a ChatGPT extension. So those have kind of written prompt to fix your, like those have a specific prompt to fix your code cells. So you can just select, and they have some features like fix, refactor, explain, and you can easily integrate those ChatGPT with your Colab notebook. So that extension, I really found it very helpful. Like I think like there are positions open already for prompt engineer with a very high range salary, but those positions basically need your prompt engineering skill. Yeah, like the position is prompt engineer, but it requires your prompt engineering skill. And this is something I found like very much overlooking maybe at the beginning of the like generative models, because when we got those AI models products in hand, we were just trying to play with this. But now slowly the people are understanding the importance of prompts. And yeah, I have like kind of ran some experiments, and I found that like it really has an impact, one like how you are writing your prompts, and your model will be responding very different for different prompts. Yes, of course. Like ChatGPT is a tool, but how you will use it, like how you will provide the input, which is the prompt actually, that is totally based on the user. So that's why, like, I think sometimes we blame the model that okay, this is the problem of the model. Maybe the model is not doing good. But I have seen couple of examples where the same model, like the same tool, is performing way better with a different prompt, maybe than the one you just wrote unmindfully, or you just wrote it that okay, let's try with this. Yes,
So,
I think like I would like to share a very interesting experience with the ChatGPT tool. So once I just wanted ChatGPT to provide me some papers, because like sometimes citations is a very tedious work. So I just wanted some paper on a certain topic, and I wanted it to give like bib takes, or the citation reference for each of the paper. So they gave me a list of papers, and like with very eye-catching names, like you will not like distrust those names. So I just wrote all of them, and I was just interested to look one of the paper, and I tried to find it, and I didn't find it online. So I just asked ChatGPT that you provided me all the wrong information, and it told me that okay, this is kind of made up information. So this is more I did based on like a novelist. So this is how they work. Like if you if they don't have any information, they try to make it up for you. So sometimes I mention in my prompt that uh, don't give me any information which doesn't exist or for which you don't get the URLs or links. Yes, exactly. Like I think like I really found it very funny when I got the response from ChatGPT. Like it was a very cute confession that okay, I was fictional when I was writing it. So it's based on I tried to be more into fiction. So I was like, no, like this is not where you can be fiction maybe, but like nowadays I found like recently I figured out like they can provide you some information, but they mention a note that these are fictional. So they ask you not to trust them, you know. So I think those are level of limitations of machine, because they cannot know where replace the human, they can assist us. And obviously like these types of information, it comes of because I don't blame the designers or the data that has been like trained for the models. Because if you think about, let's say, Siri or any other voice assistant, and you say, hey Siri, do you know this information? And Siri says nothing. Sometimes Siri, I don't have an answer for that. Sorry. But anyways, like if the like Siri or any other model doesn't respond to you virtual assistant you will not feel good. Rather, if it gives you some information, maybe they're wrong, you will still try to accept it in a way that okay, it's just a virtual robot. It tried from the machine perspective, but it couldn't respond. But if it doesn't give you anything, in that case, as an user, those are there are kind of studies on those. You don't accept those good as a user. Like your user experience with those types of applications are not good.
Yeah, and we rely so much on so much of these things, as far as even like Google. It's not necessarily AI per se, but just our reliance on technology, even our reliance on our Alexas and our Siris, even our reliance on Google Maps to get places. And that's a gap that I see that I'd love to see filled. Like this is one of the things when we talk about accuracy and how is it fantasy or is it accurate. One of the things I was playing with, so with data, like we want to create a data set. So like in machine learning, you said it starts with the data. And so I was asking it, like, because with Bard, you can ask it to create a table or create like tabular data. And then you can say, add to a Google Sheet, and you have a spreadsheet.
Hmm.
So I would love to see in the future, because cannot do it now. It can do about 5, and that's it. That's its limit. If you were to say, can I get fire stations in San Diego County? Can I get, I know I was asking it, like fire stations in the city of Oceanside? And it could give me about 5, 6, 7, and then it would just tap out. Like it was like, or can you give me a list of high schools? Can you give me a list of hospitals? And I think like in an emergency management situation, it would be fabulous if the center points were right, if it was really accurate data that you could get it to generate if you wanted to actually put data on a map, that instead of having to look for existing sources, that you could actually have it generate this data that you're looking for.
Yeah, that's true.
It can't do it right now. That was like a huge limitation. Is like
Yes.
it gets to the idea that it's like, oh, I can create a spreadsheet for you, but it's quite limited in what it can actually put on that spreadsheet.
Yeah, of course. Like since we didn't have this tool, our limit, our expectation was not this much demanding. But I'm finding like sometimes me demanding a lot from like the language model tools. All right, because like when you are as an user and you get used to get those stuffs automatically, your level of expectations also increase. For example, sometimes if you ask for code from ChatGPT, like for Google Colab notebooks, it gives you all the code together, but you don't like it. You want it to give you the things cell by cell, exactly like what will be easier for you just to copy and paste maybe in your Colab notebook. So we are, as a user, we are being over demanding to our because those are for me, I consider them as personal robot, right?
Yes. And I do the same thing with it because I'm not necessarily writing in notebooks. If I'm writing it in, actually, that's a really good point, because if you're writing in notebooks, you want it line by line. But if I'm writing it, for example, in my app.js, I'm writing in JavaScript, I want the whole block. I'm like, don't break it up for me, because I have to separate. I'm just like, no, just put it together. Make it one thing that I can copy. And so I have to ask it for that specifically. So I think, I think, like I said, I think we're all, and this is kind of a message that I have for everybody, is like, I think we're all going to have that function of being prompt engineers for ourselves, for the things we want to do, for our jobs, to know how to use these tools. I think the same thing with coding. I think now that I see what coding can do, I'm like, oh, this is really great. And even in GIS, I've been doing these interviews, and I was talking to 2 women on GIS day, and one was like, I don't code. I know nothing about coding, and she does her job very well. Not a coder. The other woman has a degree in math and computer science and could not imagine her job without coding. So not everybody needs to code, but if you are open to learning it, it can definitely take your work to a whole different level. And I feel that way in my GIS studies. I am in my 4th semester of my GIS studies, and only last semester we did an SQL course, so I was learning how to use databases. This semester we're doing a GIS programming and customization, so it's really got us working with Python and notebooks and customizing GIS. And like, that's why this is my final project that I was just showing you on sustainability for the Port of Long Beach, because we're showcasing our ability to use coding to customize GIS. So I think that like these roles, and then same thing with data, like data is everywhere, and we are awash with data, and data for visualization, data for storytelling, data for communication, decision making is so important. And I don't think it's just like, oh, there's the data scientist in our company, I'll just give it to them. I think all of us need to sort of have better ways that we can find, organize, clean, use data in just so many functions and roles, can benefit from sort of that basic understanding of data analysis and data visualization. Even if it's us on the other end of it reading a data visualization, knowing what questions to ask in terms of where was the data from, what kind of bias does it have, all of those really important questions. So I think all of us need to become more data literate.
Yes, like as I mentioned before too, like understanding your data, that's a very important task as a data scientist or as a machine learning engineer. Like we need to understand our data, because we are the one who are like fasting every steps of your machine learning model, and we will be the one who will be using it. So that's a huge responsibility. Like I think that's one of the part of AI responsibility when we are working with data.
Yeah. But I guess where I'm seeing, and this kind of is an echo of a conversation that I was in a webinar, and they were talking about cybersecurity. And they were saying like how a lot of the actual real challenges and the real risks are actually intersectional. Like they require multiple disciplines. So the person who just came out of like the very organized, structured cybersecurity course is good, but doesn't have enough. They also need to be thinking about risks that come from disinformation, risks that come from, financial fraud, risks that come from like all sorts of other things that are at play, that it could be AI safety risks, like all of it, like being able to sort of see multiple dimensions of risk and how they need to operate in this world that is not so siloed. It's very intersectional, I think. And I think that's what's interesting. And I think same thing, like we were saying, like know your data. And as a machine learning expert, eventually you can also, consider being sort of subject matter expert as well. in various fields that you're applying the machine learning to.
Mhm.
Do you see yourself being machine learning expert and then showing up in any industry? Or do you see yourself machine learning expert within a particular industry, whether that's the tech industry or applying it in other fields?
Um, well, for me, like I see myself like as a machine learning. Not, I would not say I'm a very much expert still, but yeah, I at least consider myself, having some knowledge about machine learning to um, explore like different types of domain, which I already have worked. For example, um, I think in 2018 I worked on those diabetes project, which was a very simple machine learning project that was a just a classification tool for predicting the earliest diabetes risk for people. And those data was again very interesting to collect because there was no such data set. And me and my team, we built the data set for the first time, and like this is one of my highly cited work. Maybe because like we brought up with some data which was not present at those moment. So those data was very different, or those domain was very different than the one which I have done later. For example, in another research project I have worked on telemedicine data during the COVID. So we had a huge data of COVID call records of telemedicine from Bangladesh, and like we worked on that. Then again, when I worked with the NRC project, this data of defective image parts of railway, which has no connection with the health data, this was very different because my previous projects, those are mainly electronic health records data, and these data are way more structured or less complex than the image data. So I would say, like, yeah, I see myself exploring different domains, because once you understand the fundamental or rudimental basics of the models, like where you can contribute or how you can design and implement those steps, you like, I personally want to explore multiple domains as a machine learning engineer.
I love that. No, that's great. I love that. I just was curious, how it works in terms of, because I haven't really found my home. Similarly, GIS is one of those things you can apply in so many different domains. I like. I was going to say I came out of a master's in urban planning, and that's what led me to sort of say, "Ooh, data visualization. Ooh, data science. Ooh, GIS." And then I think my interests are climate impact, sustainability, and national security, and kind of geopolitics are sort of the areas that I find interesting. And for some reason, all of my research projects keep leading me back to ports. I have done so many port projects. So this actually research that I've been doing these last kind of 2 weeks is actually building on my capstone project that I did in urban planning, where we also did the Port of Long Beach. So I'm very familiar with this port. My knowledge of it isn't just something that I kind of put together in a week. I've at least now been like working on it for semesters. So I'm hoping, like I said, what the story I can tell expresses that I have some interest and sort of time into kind of learning about it. But it intersects with actually what you were talking about. If you actually want to put rail and health together, that is the story of the Port of Long Beach, because they've got ships, they've got rail, they've got trucks, and they've got a local community that is
Yes.
deeply, deeply impacted from a health perspective because of the toxic nature of a port.
Yes, of course. Like there is always a point of intersection. For example, when I told one of my colleagues that okay, I'm gonna start with the railway image data, and she was very much wondering. She said that's a very different one than the one you work with. But I was like, yes, but I think both of them are diagnosis. So kind of they are targeting the same goal. So in case of health data, I'm trying to predict or classify the diagnosis for the patients. In the on the other hand, for the railway, I'm trying to diagnose the defective parts, for the railway. So it's two different industries. The data natures are different, but still there was a common point that I can carry on from my previous learnings and put it back onto the new one.
Well, I also think it's important because as you're building your portfolio,
Mm-hmm.
you're not pigeonholing yourself like, oh, I'm the healthcare machine learning person. By doing a diversity of projects, you say, yeah, if you need me for a healthcare project, I'm open and available for that. But if you need me for an industry, commercial,
Mm-hmm.
transportation project, I can do that as well. And so I think you kind of having and I think that's something I'm going to be thinking more about as I come into the new year is
Mm-hmm.
what do I want my portfolio to be? What do I want to use the
Mm-hmm.
things that I'm building to showcase and to say? And so I think the Port of Long Beach one actually
Yeah.
ties together the fact that and kind of calls attention to the fact like I have a degree in urban planning. I have I'm studying GIST, and then my actual official Master's of Science is in Human Security and Geospatial Intelligence. And so human security can be based on war, it can be based on climate impact, or it can be, based on sort of environmental justice, which this one is very much kind of grounded in.
Yes, of course. I am here in Ottawa working with the Multimedia and Communication Research Lab, which is known as MCR Lab at the University of Ottawa. And as the name refers, multimedia, they work with different, multiple types of media. So currently the projects I'm working on, that is again a very different case than the one that I have worked before. Like now I'm more working on generating challenging and creative contents. So one of those are for metaverse. So this is kind of again way different than the one that I have worked before. So but still you are trying to generate some data. I'm again working with some AI models, and of course I'm using some takeaways from my previous projects and then exploring it in the different field or in a different application domain. So that is very interesting sometimes to explore, understanding the nature of the data, and also how you as a machine learning engineer uh, make those data useful, or you process it with the machine learning models, and then you provide some prediction or classifications. I love the journey, to deal with different data.
Oh, that's fantastic. I'm obviously literally a student, but also figuratively a student. I think I've found something that I can remain passionate with because there's sort of a lifelong learning aspect to it as well. We're always kind of figuring things out. We're
Mhm.
always sort of putting ourselves up to new challenges that we're kind of sometimes have no idea how we're going to do it, but we kind of get through it, use the training and skills that we have, and figure it out and ask questions along the way from our communities and sometimes our AI,
Mhm.
and just kind of, and like you said, live with the data.
Mhm. That's very interesting, but yeah, that's how I learned the things. It's kind of exploring and researching and then summarizing, but of course, it's also living with your data and understanding your data, and kind of learning by doing. Also, I would not say it's a trial and error, but of course it's sometimes learning by doing. The more you play with your data, the better you understand how you can make some uh, useful decision, or useful information out of those data. Keep following your dream, and focus on the work that you are passionate about. I have found myself always not being tired to work on something that is I'm passionate about. We should, we have one life, so we should be happy what we are working about, right? So of course, I think when I teach, when I give a lecture, it's about always the 3 hours lecture. but I really feel good and very much fulfilled after I give a lecture. Like usually people tell me that, okay, you talked for 3 hours, you are not tired yet, but I feel more energetic. I want to talk more. So yeah, so I would request everyone, and I would tell everyone that, okay, choose the job that you are passionate about. Like you will be happy.